All right, so this section is on combining like terms, and I'm breaking it up into two parts. We're going to focus on the first part today just to get comfortable with it, and then there's a second part that still is to come. But you need your notes in front of you and something to write with and a level of focus. Don't turn away, because sometimes you come back and you're like, what is that? So stay focused, let's get going. All right, so combining like terms, the first thing I want you to do is take a quick moment and group the like terms together, determine how many of each there are, how many popcorns, how many movie boards, and then pause it now and turn it back on when you're done. All right, so you should have seen there's 14 popcorns and there's 4 movie boards. Okay, notice they're mixed up, but you had to just figure out how many of these and how many of those. And that's kind of what combining like terms really is all about. So let's break it down first. Bullet point right here. Like terms can be combined in a similar manner. A term is considered like if it has the same variable with the same exponent. You will see some examples of this shortly, but we got to first understand what are like terms. And another bullet point right here, constants can also be combined with each other. And just a reminder, constants are numbers all by themselves, no variable attached. Now, let me show you some examples of what this really is. Let's assume that we were going through the drive-through and you ask your family what they want, and someone says 2 burgers and a fry and a soda, and somebody else is like, yeah, I want 3 burgers and 2 fries and 2 drinks, and you're just kind of like, wow, you guys are hungry. But we could show this algebraically. We could say, that's 2 burgers right there, plus a fry, plus a drink. So far we've described that. Plus 3 burgers, plus 2 fries, plus 2 drinks. Now that's showing this part. Now, there's things here that we can group together, right? You see the burgers and you see the fries and the drinks, and if we really wanted to do this, to summarize it, we could simply say, you know what, that's 5 burgers, 3 fries, and 3 drinks. So algebraically or mathematically, we would say this right here is really this, 5 burgers, 3 fries, 3 drinks, okay? So this is kind of what combining like terms is, but this is a real example of kind of how this plays out. Now, a few reminders. You need to make sure you remember these things. First of all, we need to know what a term is. So if I look at this expression right here, there are 4 terms in this expression, 2x, negative 4y, 7z, and 3. Notice I said negative 4y. We'll come back to that later. Sometimes people are like, but that's minus 4y. We'll get to that later. But there's 4 terms in this expression. Terms are basically numbers, variables, or products and quotients that we're adding or subtracting. So this problem right here is made up of 4 different terms that we would combine or subtract. Now there's also variables, which you know what those are, letters that stand for numbers. There's also coefficients. You should remember what this one is too. Coefficients would be the number being multiplied by a variable. So 2 is a coefficient. Negative 4 is a coefficient. 7 is a coefficient. Those are coefficients. There's also constants though. Constants are numbers that don't change their value. Like this 3 is a constant because it's not attached to a variable. It is constantly representing 3. Down here, if I have this expression x plus 2, this 2 is a constant because it's representing 2 and that doesn't change. Now, these other values, they're not constants because they're changing depending upon what x is worth or what y is worth or what z is worth. So these are some reminders right there. Now, let me show you some examples of like terms versus unlike terms. These are all like terms because they have the same variable to the same exponent. Okay, so 2x and 19x, we can combine those like terms, but these ones we can't. What do you notice that's different about those? You're right, they have different variables. You can't combine this one with that one because you have a different variable. Right here, like terms, but right here, unlike terms, because what's the difference? This one has an exponent of 2, this one doesn't. So those are unlike terms right there because of different exponents. Right here, these are unlike terms, again, for the same reason as this first one up here. You have different variables. What about this one? What makes these unlike terms? Well, it's the exponent again. This one is 32a squared. This one is 9a cubed. So we have a different exponent, so no combining those. And these are unlike terms because this is a constant and this one is not. All right. Now, these are all like terms over here. We could combine these if we wanted to. This would be 13y. This would be 41a squared. This would be 2.2r. So really the coefficients are important. You're really just adding or subtracting those coefficients and keeping the variable attached. So the lesson here is don't break the law by combining unlike terms. You don't want to be doing that. Now, what I want you to do now is I want you to look at this box right here, use a different shape or color to group the like terms together, and then explain your thinking. So draw boxes around anything that has an x squared, circles around anything that has an x, pentagons around anything with a y, and trapezoids around the constants. And they also want you to group them together. So figure out what those squares add up to, what those circles add up to, and so on. Pause it, give it a shot, and then we'll come back. All right, so this is what you should have found out. You should have found out that there was really only one 3x squared. So that's the only one that had an x squared. For the x's, that's all of these. And if you combine those, you end up with 27x. Again, you add your coefficients. 11 and 7 is 18, plus 4 more x's would be 22, plus 5 more would be 27x. The pentagons, or the y ones, would have been 49y, and the constants, the numbers all by themselves, would have been 51. Now, we're just getting going here, all right? Now we're going to look and see how this applies to some problems. Practice simplifying these expressions by combining the like terms below. So if I want to show some highlights here, if I look here, I have a 6x, and right here I have a 12x. Now I can combine those because they both have the same variable attached. I cannot combine them with this one though, because that's a different variable. So if I add my coefficients, I get 18x plus 3y, and I stop there. I can't go further. Sometimes students think, yeah, you can add them and get 21. Well, no. Again, you have different variables, so don't do that. Stop here. That's where the problem stops. Once we know more information, we could keep going, but they didn't tell us what x's value was or y's value. Look at the next one. Let's look at that. I see a constant and I see another constant. So I can add those together and get 14. But the 11y I have to keep separate. So that's how I would simplify that one. 14 plus 11y. Now look at the next one. 6x plus 2y. You should be realizing that you can't combine either of these because they have different variables. So these are unlike terms. So really, I can't do anything with it at all. That ends up being exactly what it started with. Okay, I can't go further and say, well, yeah, but I can get these and get 8. And no. Again, you have different variables and you can't combine unlike terms. That's a math rule right there. So that's what we're looking at right here. Now, one thing to keep in mind, the goal of doing this is to create an equivalent expression. When they say simplify or evaluate the problem or solve it, you're really wanting to come up with another solution that's equal to what you started with, or that's equivalent to what you started with. Now, we understand equivalence with fractions. We know that like 1/2 is the same as 3/6. But we're also learning that this equal sign is very important because it means what's on the left should be equivalent to what's on the right, whether it's division, whether it's multiplication, whether it's just a basic balance. Okay, I know 2 plus 2 is 4. That equal sign tells me that the left side of 2 plus 2 is the same as the right side, 4. So this is about equivalence, okay? Math is about balancing things out. And if we look at what we're doing today, if we were to collect these like terms, the ones that are underlined in red, we would get 6a. And if we were to collect these other ones that are underlined in green, we would end up with, a new equivalent expression. all right? So that's the goal here, is you keep in mind it's all about equivalence. Now, there's also something to think about with subtracting like terms, okay? Like terms can be subtracted, but remember to keep the sign as a part of the term. We'll get to that in a moment. We want to use our rules for integer operations as we combine terms. If I think about this one, if I have 6c and I want to subtract 5c, well, that's really just 6 minus 5. But I keep the c attached. Now I can say 1c, or I can just say c, because this is kind of like, think of it like this way, 6 carrots minus 5 carrots. I'm left with 1 carrot, or just a carrot. If there's no coefficient, the assumption is that that's a 1 in front of it, and we're okay to write that or to not write the 1. If I look right here, 13c minus 5c, well, look at your coefficients. And if you subtract them, what do you get? You get 8c. Now, this is going to happen sometimes, where if you look at this one, I have a 14x and I have a negative 8x. So I want to group those together and think of this as a positive 14x because there's no symbol out front. And think of this as a negative 8x. That's really just taking away 8x's from that one. So my first step is usually just to group the ones together that I can. And that in this situation is these two. 14x take away 8x. That's what it says right here. Remember to keep the sign as a part of the term. So that negative 8x or subtract 8x, I got to think about it in combination with the 14x. And then I also have the plus 3y still. So I'm going to keep that separate because it can't be combined. But I can combine those, and what happens when you do 14x take away 8x? You get 6x plus 3y. And that's where we stop. Look at the next one, 16x minus 9 plus 5x. Again, look for what can be combined. I have a 16x and I have a positive 5x, or I want to add 5x to it. So if I take that further, that would be 16x plus 5x. And I still want to subtract 9 though. So now I can combine these two and I get 21x minus 9. So you got to pay attention to the sign in front of the other one when combining, because sometimes they're not right side by side, like these two are split. Okay, there's something in between them that we can't combine with it. Same thing here. There's something in between them that's a constant that can't be grouped with them. All right, look at this section right here. We're going to practice simplifying some more. So if I look at number 7, first thing I look for, I have an 11a and I have a adding 3a. So if I combine those, think of that as doing this. Notice I kind of grouped things together first. 11a plus that 3a. Well, that's 14a. But that minus 5c is now going to be something to factor in. So I get 14a minus 5c. And I stop right there. I do not go further. The next one, if I look at this, I have a like term here that's also the same as that one. So I can do those first. You know, it's really 16 plus the answer to the like terms. And I know that 12 minus 7 is 5, so really I end up with 16 plus 5b. This next one, if I look for like terms, I have a 4d. And I also down here have a minus 3d. Okay, I'll pay attention to what's right in front of the other one. And if I go ahead and solve that, if I group those together, I would get 4d, take away 3d, and then I still want a minus 8. So when I group those together, I get 1d minus 8, or again, if your coefficient is 1, you can just say d minus 8, okay? Because 1 times d is the same as the value of d. All right. Now I want you to try 10 through 15 on your own and pause it and come back when you're done. All right, go ahead and see how you did. What you see in red should be where you ended up. So check those 6 problems. You can pause and then turn it back on when you're done, please. All right, now sometimes they'll give you a shape like this and they'll tell you its sides, and they ask you a question like this. Write an expression to represent the perimeter of each figure below. Well, if I'm looking at this triangle right here, it looks to be an equilateral triangle and they only tell me one side. But I'm making the assumption, since it's an equilateral triangle, that really if that side is 15x plus 2.5, then all sides are 15x plus 2.5. Now, I can work this through by realizing that I have some like terms here. I have a 15x, another 15x, and a third one. So if I add those together, 15x really 3 times, I get 45x. So that's part of my answer, 45x, but that's not the only part of my answer because I also have this 2.5, 2.5, and 2.5. And if I were to really add those 2.5s, well, that's 5, and then that's 7.5. So when I solve this problem, the perimeter of this triangle is 45x plus 7.5. And that's my answer because I've combined the parts that I could and the constants as well. Now, if I look over here, this one's a little trickier because there's like some adding some constants and some subtracting some constants. Now, I'm going to show this one a little bit different. What I want you to see here is that if I were to kind of think about each of these side lengths, again, for the perimeter, you're adding the 4 sides together. So if I think of these as like an addition problem, you can think of it almost like adding things top to bottom. And if I were to draw a line right here and say, you know what, I want to add all of this, it looks a little confusing, but let me break it down simply. You can add these values together, and they're all positive. So if I add 3x, that's 6x, 8x, 11x, that's what I get for those values, 11x. But I also have these constants. But now some of them are adding and some of them are subtracting. So look at it like this, 8, take away 1, well, that's 7. I want to add 4, well, now I'm at 11. Take away 1 again, now I'm at 10. And I'm at a positive 10. So I'm going to show that by adding 10. So these sides all really add up to 11x plus 10. And again, all we did was we combined our like terms. We combined these and we combined these right here. Now, sometimes you got to pay attention to the signs though, like there was this takeaway 1 and another takeaway 1. So you have to pay close attention to what's going on with it. Now, here's your summary. And write both of these bullet points down. It says down there at the bottom of your notes for today's lesson summary. 1, like terms have the same variable with the same exponent. Okay, that is a big point from today. We can only combine them when they're like terms. And you got to know what a like term is for that to be the case. The same variable raised to the same exponent. The second bullet point, like terms can be combined to simplify the expression. We are wanting to create an equivalent expression. So that is the goal here. All of those problems we were doing today, we were creating something that's equivalent to it. We were making it simpler. We were combining the parts that could be combined, okay? Whether it was burgers and fries and drinks, or it was, terms that had X values in there and Y values, or something squared values. So that's the summary from this lesson. All right, that's it. That brings to a close part 1. And there will be a part 2 because there's one other layer of combining like terms that you need to be comfortable with at the 6th grade level, and that'll be in part 2.